Okay, definition for ellipses. Set of all points. There's distances. From 2 points which are called foci. Foci are plural for focus. Sum to a constant. Let me kind of show you what that means. If we were to try to construct an ellipse, I'll go back to that definition. Let's say that this was one focal point and this was another focal point. And let's say you had a string and you tied the string into a loop and you laid it down and there sat the string around those focal points. If you took a pen and grabbed part of that string and pulled it tight around those focal points and then went all the way around, it would produce that shape. Sorry, that's all right. So I should do this instead, shouldn't I? Yeah. It would create, basically an ellipse like that, okay? And so that's what it would do. If you had a string and you pulled it tight and kind of just went all the way around, that's what you would get with 2 focal points. If you had 1 focal point, you would just get a radius for a circle, and you would just make a circle. So that's how it's generated. You don't have to have these focal points in order to actually draw the graph, but that's why the focal points are important. So you guys will say, why are we finding the focal points? We don't even need it. Well, that was how we had it for the directrix as well. So let's start to specify equations and values. The equation that we're concerned with looks like this. X squared over a squared plus y squared over b squared is equal to 1. That is the equation for an ellipse. X squared over a squared plus y squared over b squared equals 1. And that's where a is greater than b, which is greater than 0. You could have another form of an ellipse. The first side's horizontal, the second side is vertical. This one would be x squared over b squared plus y squared over a squared is equal to 1, where a is greater than b is greater than 0. So a is always the bigger number. A is always the bigger number. Notice a isn't on bottom, but a squared is on bottom. So we get, if a is underneath x squared, then it's stretched more horizontally. If a is under y squared, then it's stretched more vertically. Okay, so that's what happens. If it's stretched more horizontally, your vertices are going to be plus or minus a 0. Your vertices will be along the x-axis. So for example, I have a horizontal ellipse right here, and its vertices are these points. It's endpoints, kind of. And we call it negative a0 and positive a0. So you take the square root of that a squared thing, or the square root of the bigger number, and that tells you where you're at. Now, if the a squared sits under y squared, then our vertices move to the y-axis, not the x-axis. So in this situation, you have 0a, and you have 0, negative a. The major axis is the length that it's stretched out. How long is it from one side to the other? What do you think? twice the A value. And we said that it is horizontal. And how about the other one? Still twice the A value, and it's horizontal. Or vertical, excuse me. Now, the minor axis has, kind of these endpoints as well. We would call it 0b, and then 0 negative b. So the length of the minor axis is twice the b value. And in this situation, the minor axis is vertical. Again, twice b. In this case, it's horizontal. Naomi, what hour are you an office worker? First hour? Well, that's study hall. That would be fun. I would enjoy playing Anchorman during first hour study hall. You may bring all the messages that you would like. Okay. Is that clear? Let's get to focus points. I don't really hate it. Hate's a very strong word. I used that to describe Levi earlier. That wasn't very nice. I wouldn't say that I hate messages. What is frustrating me is if a message is dropped off, but the person is in my classroom. Like, what am I supposed to do? Right. But that's when I catch it. Sometimes I just take the messages, and then all of a sudden I have the support message for a person because I forgot to check, and they're not in my room. I'm like, what do I do? Ah! I know. I know. There's some inside pieces that I can share with you another time. Anyway, okay, foci. What's that? Well, it's just in terms of how things get distributed, and how we go about that process. It's something we brought up as faculty. What's the best way to let people know about stuff? But now I'm excited to receive messages because I get to play Acrobat, so I'm happy about it. Okay, so here we go. These are called your focal points, and they have coordinates. In this situation, plus or minus c. Oh, I'm sorry. So this one would be negative c. Oh, just we'll learn where to put them later on. Negative c0. So your focal points will be plus or minus c 0. Or in this case, it would be 0 plus or minus c. So they sit along the major axis. And they have this value of c. And in order to figure out c, we have an equation. And this is our equation. C squared is equal to a squared minus b squared. So it's kind of opposite from the Pythagorean theorem, so adding and subtract. Eccentricity. Any questions about foci? Where they're located? Those are the points that we use to generate it. If we place that string around there, it's kind of what happens. Eccentricity. Eccentricity is. This is not a very technical definition. I'm just going to write it. How squished the ellipse is. And Second hour didn't like this a whole lot when I started talking about it. I think they got bored right away, but I'm going to try again with you guys because you guys are a much more intelligent crowd. Back in the day, they kind of wondered about planetary motion. And what shape do you think they all thought that planets traveled in? Circles. Do planets travel in circles? No. But they were really set on this whole circle piece. And when circles didn't work out, they realized that planets do not travel like that. And so they tried to describe the motion. And remember that they were describing the motion thinking that the center of the universe was the Earth. So this made it very difficult. Well, they described the motion of planets to be this. I know that looks funny, but they thought, well, that's a circle with circles in it. So that's even kind of cooler. And when they thought about that and they tried to describe it that way, this actually accounted for planetary motion viewed from Earth really, really well for like thousands of years. It wasn't until much later when calculus was discovered and whatnot that we understood more about planetary motion. But we do understand now that planets travel in the form of an ellipse. And the eccentricity of the ellipse is very important in planetary motion. And it's really how squished it is. So like this would have an eccentricity value of like 0.01. Okay? It's not very squished at all. But this would have an eccentricity value of say like 0.95. It would be very, very high. It would be very squished. So as we talk about eccentricity, we're talking about how squished it is. And the way we calculate E is equal to C over A. And 0 is less than E, which is less than 1. It's always a value between 0 and 1. And again, eccentricity is not something that you have to know in order to graph it, but it's kind of cool. You know, you could tell your parents can ask, you know, so what'd you learn about today? Oh, I learned about the eccentricity of planetary motion. Oh, wow, you're pretty smart. What class was that? Astronomy? No, it was math class. We just learned about everything in math class. It makes you really smart. Say, hey, Mom and Dad, you can get the education for free because you can go to YouTube and watch it. Now see if you can pass my math test. Take that. All right, okay. Sketch the following graph. Find vertices, foci, eccentricity, major, minor. There we go. So we want to find all 5 characteristics and we want to graph it. This is going to be no problem. You guys are going to be really good at this. You're smart. All of you. I've got a little graph there, and I'm going to talk about A, B, and C. Those are important parts to my graph. A for the day. Who knows what A is? You're both wrong. I mean, what are the odds? 5. A is always the larger one. A is the larger one. A is the larger one. Look at your formula. It says x squared over a squared. Y squared over a squared. Okay, so it's the squared value. So that means that if you see 25 and 4, your A and B values are 5 and 2. It's always the square root of the bottom. Okay? So A is 5. What is B? 2. How do I figure out C? A squared, which is 25, minus B squared, which is 4, gives me 21. So C is going to be the square root of 21, which is about 4.6. So is this thing stretched vertically or horizontally? Vertically, why? Because the bigger number sits under y squared, therefore it's stretched vertically. So it's stretched vertically 5 units. And it's stretched horizontally 2 units. A squared minus B squared is equal to C squared. So that's how I got the square root of 21. Okay, there's my ellipse. I sketched it already. Okay, no problems. What are the vertices? The vertices are the endpoints of the major axis. Very good. So I can write it as 0 plus or minus 5. The foci lie on the major axis. So I have 0 and plus or minus the square root of 21. It's about 4.6. I'll put those on there. You can see where those focal points are. The eccentricity. How do I calculate that? C over A, or like 4.6 divided by 5, which is 0.92. Something like that. So this is a pretty squished parabola or ellipse. What's the length of the major axis? How long is the major axis? 10. What's the length of the minor axis? 4. That's it. The major axis is this length, so it's twice the A value. And the minor axis is this length, which is twice the B value. What you think about that, Whitney? Okay, let's do the next one. B. We've got 4x squared plus 9y squared equals 36. Why is this more difficult? Yeah, we got to make it in the form. How do I make it in that form? Divide by 36. Divide everything by 36. It's got to be equal to 1. Very important. So we've got x squared over 9er plus y squared over 4 equals 1. Mi español muy bueno. Muy. What did I say? Yeah, muy. Muy. Whatever. All right. Yeah. You stick to drawing then, mister. You could use some improvement in that area, Nathan. Yeah, you bet. All right. I took it for a semester. Yeah. I had to choose. Did I take Spanish, or if I took Spanish, I would then have to drop either AP English, AP History, or Physics. Yeah, I'd have to drop one of those 3, and I said, no. Nope, you guys don't have to have 2 years to get into college either. If anybody's ever told you have to have 2 years, they lied. It's recommended, but you don't have to. I walked into St. Olaf, they said, we could care less. We want you. I said, by the way, you have to graduate with a language from here anyways. Yep, everybody from St. Olaf has to graduate with a language. So that means when I got there, if you took 4 years of Spanish, but you only tested in Spanish 2, you have to take Spanish 2, 3, and 4 before you get out. So I came in there, and I basically didn't have a language, so I took 4 semesters of Greek. It's great. But everybody at St. Olaf graduates with a language, part of the requirement. Yeah, it's very hard. Okay, let's do this, okay? I know that I'm really interesting, but let's pretend math is more interesting. Was that funny? Yeah, that was funny. Just like that. Okay, so I should figure out A, B, and C. A for the day. What's A? 3. Good job. What's B? 2. What's C? Square root of 5. Oh, Nathan, you were almost correct. 2 out of 3. That's 66% of D. All right. So we've got 3, 2, and square root of 5. Is this thing stretched horizontally or vertically? Horizontally. Why, Naomi? Big numbers on the X. So I go 1, 2, 3, 1, 2, 3, 1, 2. So these are the points that are going to give me my shape. There, we've got it. So what is the location of the vertices? Plus or minus 3, 0. The foci? Plus or minus square root of 5, 0. Eccentricity. If you take the square root of 5 and divide it by 3, you get approximately 0.75. So you can see that this one is less squished than the other. What's the length of the major axis? 6, minor, 4. Piece of cake upside down. What do you think of that? You like that? You like it? Let's flip it over. What? You got it, Whitney? Oh boy. Write equations that will allow you to graph the following ellipses on your calculator. True or false? An ellipse is a function. False. Why is an ellipse not a function? Does not pass the vertical line test. Very good. So, if you notice, most of the time when you graph stuff in your calculator, now we have ways around that, but most of the time you put stuff into y equals. And so, you know, this isn't solved for y. So we're going to start with letter B, and we're going to solve for y in order to graph this in our calculator. If you're going to solve for y, what would you do first? Minus the 4x squared. I get 9y squared is equal to 36 minus 4x squared. Then what? A lot of people second order want to square root all that. Yeah, you can't. Don't do that. Divide by 9. 9. 9. Y squared equals 4 minus 4/9 x squared. Now what? Now square root both sides. And you can't take the square root of parts. Y equals. Watch. Excellent question. The square root of 9 minus 4, would you agree that that's the square root of 5? If you take the square root of parts, you get 3 minus 2, which is 1. And these are not the same. Does that explanation work? Very good. So we go square root of y squared is y equals, and we take the square root, we get plus or minus square root of 4 minus 4 over 9 x squared. Beautiful. Let's see if we can graph that on our calculator now and get an ellipse. Y equals. Well, because the positive will give us the top half, the negative will give it the bottom half. That's what's going to happen. Yeah, so we got to type it in separately. What? To be able to graph it on your calculator, if you want to be able to view it, then that's what you have to do. No, but that's helpful. If you want to see that you did these correctly, then this is something you want to be able to do. And I will say in calculus, yeah, we're always changing stuff like that, the square roots of whatever. So you need to be able to do this. So we go 4 minus 4/9 is 0.4 repeating. I know that. I'm really good at math. And then I go down, I go negative square root of 4 minus 0.44 x squared. Parentheses. Then I like to zoom like a box. No. Like a square. So see how this is a rectangle? If I go zoom square number 5, it will turn my screen so it looks more like it should. It's proportioned out correctly. So that's the picture of it. Now, did you notice how you kind of get these little gaps right there? Your calculator isn't smart enough to think through all that. Because it starts to draw a vertical line. Your calculator can't draw vertical lines. Yours doesn't look like that? Oh boy. We'll look at it right after we finish up this lesson. I'll make sure that we figure that out. Okay? So, that's how we graph it. Plus or minus. You got to enter them both in. You get the top and the bottom. Okay. Question. A. before I solve for y squared, or for y, what should I do first? Multiply everything through by 100. Very good. Let's multiply everything through by 100. So I get 100x squared over 4, which is 25x squared, plus 4y squared equals 100. And now we just go about that process again. Minus 25x squared. 4y squared is equal to 100 minus 25x squared. Divided by 4, y squared is equal to 100 minus 25 over 4 x squared. Square root both sides. You got the plus or the minus. What? Sorry. Yep. So 25 minus 25 fourths x squared. So we're not going to graph that. You guys know how to do that, but that's just the basic idea. Okay. I just thought that would make it easier. Play with numbers a little. Okay, we do these last two. Okay. Write an equation for the following ellipses that satisfy the given conditions. You guys recall that ellipses have the form of x squared over a squared plus y squared over b squared is equal to 1. Or the a squared and b squared could be switched around. So in order to figure this out, a lot of times the values I need are a, b, and c. You tell me if the focus sits at 0 plus or minus 4, and if the vertices sit at 0 plus or minus 5, which of these do you know? I know A and C. What's A? 5. What is C? 4. How do I find B? C squared equals A squared, which is 25, minus C or minus B squared. Oh, I'm sorry. I'll slow down. Going too fast. A squared minus B squared. C squared will be 16. A squared is 25 minus B squared. We subtract the 25, negative 9 equals negative B squared. Divide by negative 1, 9 is B squared, so B is 3. So I've got those values. You tell me, does the a squared value go under x squared or does it go under y squared? Why, Samantha? Yeah. The vertices are the endpoints and it's on the y-axis, so that means it's stretched vertically. So my a value, my a squared value goes under y squared. So my equation would be x squared over b squared, which is 9, plus y squared over a squared, which is 25, equals 1. Let's try one more. Same thing. Endpoints of plus or minus 2 square roots of 2 and 0 on the minor axis and a distance of 10. I will be looking for A, B, and C. Any idea which one of these I know already? C is 5. How'd you get that, Parker? Yeah, if the distance between the foci is 10, then that means that the C value will be half that distance, which is simply 5. 5 units in each direction. Good. What else do I know? I know B. B is 2 square roots of 2, because that's the minor axis. How do I figure out A? C squared equals A squared minus B squared. C squared is 25. A squared we don't know. What's B squared? 8. $33 is A squared, so A is the square root of 33. You tell me, is this thing stretched Vertically or horizontally? Vertically, because the minor axis, the endpoints of the minor axis sit on the x-axis, so therefore this thing is stretched vertically. So therefore my a squared value will again go under the y squared value. A squared is 33. B squared is bada bing, bada bam, bada booski. There you are. You guys can do it. This stuff is a piece of cake upside down. You know that you have class tomorrow and Thursday, but because so many of you will be gone, raise your hand if you're gone either tomorrow or Thursday, one of those 2 days. Oh, that's it? Oh, well, good for you guys, because my second hour is missing either Wednesday or Thursday due to something with humanities, social, or something like that. So what's going to happen is that between Wednesday, Thursday, and Friday, we will either have 1.5 days of class or 2 days of class, but we will not have 3. So especially between Wednesday and Thursday, one of those days you have a work day, Wednesday or Thursday. I don't know about Friday. Raise your hand if you're gone Friday. What? All right. I'll try to figure out what we're going to do. There you go.